there are 2 or 3 different ways that you can sort of mentally visualize what's going on here. So I don't know, I'm always a bit worried about confusing by going through more than one idea, but we'll just see how it goes. So I'm going to try and explain how this works in more than one way, and then you can pick up what you can from it as we go through. So first of all, well, let's look at that. We've seen formulae already. They're like recipes. They tell you what to do. And we've seen this formula already to find the pressure in a liquid or the atmosphere, knowing these values, H, rho, and G. Remember, they represent numbers. We just don't know what they are. So to use this formula, I need to know what H is, rho is, and what G is. And we've done one of those examples. And then we can key them into the calculator. If I know H, rho, and G, what do I do with those numbers, Chris, to find P? If I knew what that was and that one and that was, what would I do with those numbers? Times them, right. No symbol means multiply. So I multiply that by that by that. Would it matter if I wrote rho HG? No, because it doesn't matter the order that you multiply, does it? Okay? So the order at which I put these things doesn't matter. Now, at the moment, P is the subject of this formula, because it's on the left-hand side. It's set up to find P. P is the subject. If I want to change the subject, that means I'm going to rearrange the formula so that it reads H equals something, or rho equals something. If I wanted to find the depth or the height, the depth or the density of this material, I'd need to rearrange it. So what I have to do that is to undo the right-hand side of this formula until I'm left with H. So if I want to make H the subject, I undo, and that word I think is helpful, undo the right-hand side step by step until I'm just left with H. That's the idea. And how you do that, there's different ways to do it, different ways to think about it, but that's what we're trying to do. We're trying to get rid of the rho and G. If I got rid of the rho and I got rid of the G, I'd be left with H, and H would then be the subject. Undo the right-hand side. So, yeah, shorthand for right-hand side. Right-hand side, left-hand side. Okay, so let's rewrite the formula. And I want to make H the subject. So when you look in the textbook and you're asked to rearrange a formula, then that's usually how it's written. But in a bracket by the side of it, that's what I'm going to try and make the subject. What I do is I look at this right-hand side and I ask myself, and this is the thought process that goes through my mind, what's happened to the right-hand side? It's H has been multiplied by rho and multiplied by G. It doesn't matter whether I multiply by rho first or G first, but I'm multiplying by those two. So I can think of it as I've multiplied it by this term, these two elements, rho and G, rho G. So if I've multiplied by rho G, how do I undo multiply? Divide. So I divide by rho G. Divide both sides by rho G. So to undo, multiply, and I use that abbreviation for multiply, multiply by rho G, that term rho G, we divide by rho G. There's the formula. Divide by rho g. And if you think about it, dividing by rho gets rid of the rho. Look, they cancel each other out. I could cancel out the rhos. Dividing by g gets rid of the g. I can cancel out the g's. So that's how some people think of it. If I divide by rho, I'm cancelling it. If I divide by g, I'm cancelling it. I like to think of it as I'm undoing the step. I'm undoing multiplied by rho by dividing by rho. However, if I'm going to divide the right-hand side by rho g, because this equals means whatever's on the right must be the same as what's on the left. If I'm going to divide by rho g, what must I do to the other side? Divide by rho g. Whatever I do to one side, I must do to the other side to keep it balanced, to keep the equation, or the formula in this case, balanced. So long as if I do something to one side, so long as I do the same thing to the other side, it's still balanced. So if I'm going to divide by rho g, I must divide the left-hand side by rho g. I don't know why it's not allowing me to extend the page. So now, if we divide the right-hand side by rho g, we must do the same to the other side, or the left-hand side. And you're left with P over rho g equals h. It's traditional to write the subject of the formula on the left. So once we've got to this point, we would then write it h equals P over rho g. It doesn't matter which side you write first, but we always write the subject on the left. So the last step would be to write the formula like that. Okay. So just to quickly recap this, got a formula, P equals h rho g. At the moment, P is the subject, but I want to make h the subject. And this is the generic thing we do with any formula. We ask ourselves the question, what have I got to do to the right-hand side to undo the other terms, the other elements rather, apart from h, which is what I'm after. I've got to undo, get rid of the rho and g. If I've multiplied by rho, divide by rho. If I've multiplied by g, divide by g. So I can do the two at the same time, so I divide both sides by rho and g. And that's how I might write it. Just write it as this, okay? Divide by rho g, divide by rho g. And then I can cancel out the rho and g. So as you get more used to this thing, you can sort of speed up these steps. Divide both sides by rho g, and then write h first on the left-hand side. And I've rearranged that formula. Now I've rearranged the formula and made h the subject. So I could use this formula now to find the depth in a liquid for a particular pressure. If I want a particular pressure, then I can find the height required to give me that pressure. Rearranged. Here's another formula. This is Ohm's law, but actually written in a slightly different way, and it's interchangeable, the letter E and V for voltage. E is often used in electronics to represent the EMF. So I equals E over R could easily be another representation of formula. But this time, what's the subject of the formula? I. I equals E over R. It's set up to find the current. I want to rearrange it to find R. The trouble is, R is underneath. So the first step is to get R on top. And what I do is I multiply. If I multiply the right-hand side by R, actually I'm getting rid of the r on the right hand side, but if I multiply the right hand side by r, I must also multiply the left hand side by r, and then it'll be on top. So if the value I want, in this case r, is on the bottom, then multiply both sides by this value to get it to the top. So I equals E over R. That's the formula as written. I'm now going to multiply this side by R to get rid of the R on the right hand side. So I also multiply the right hand side by R. Multiply both sides by R. I've not changed it. Now that means I can cancel R this side. That's disappeared. By multiplying, I've got rid of the divide by R, and I'm just left with E. So I've now got IR, or RI, doesn't matter which order I write it in, equals E. Remember what we're trying to make the subject R. So what's the next step to get R on its own? What's the story for this left-hand side now? R has been multiplied by I. How do I get rid of the I? Right. Now divide by I. To leave R on its own. So rewrite it. I'm going to divide by I. So I must divide the other side by I. Divide both sides by I. Whatever I do to one side, I must do to the other. Now i's cancel, and I'm just left with R. So R equals E over I, and I've rearranged the formula. I'll just pause. So to recap this one, I want to make R the subject, and I did this example because often in a formula, the thing you're trying to make the subject happens to be underneath, and in that case, the first step, generally, not always, because it depends on the formula, generally is to multiply through by what you want to make the subject, and that gets it to the top on the other side. So if I multiply both sides by R, here's the original formula here, I equals E over R, multiply both sides by R, and you can see that the R's cancel on the right hand side. So I'm just left with R times I equals E. There. Now that means at least that the thing I'm trying to isolate is at the top. All I've got to do now is get rid of the I, and as we were discussing, if R is multiplied by I, if I divide by I, I'll get rid of that effect, that I. So divide both sides by I, that'll just leave me with R equals E over I. And I've rearranged the formula now for R, to find R. So this example, to make U the subject in this formula, V equals U plus AT, this formula is actually one that you'll come across when you start looking at mechanics and motion and stuff like that. It's one of the equations of motion. V stands for the final velocity, U stands for the initial velocity, A the acceleration, and T the time of some object. So a familiar formula. I want to make U the subject, so I want it to read U equals something. So as we've done before, look at the right hand side where U is and ask I've got to undo and whatever has been done to this side and leave u on its own. So if we look at u, what's happened to u? I've added this term at. So what do I do to get rid of it? Take it away. If I take at away from the right hand side, I must also take at away from the other side. So take, subtract, take the term at from both sides. And I get rid of the at on the right hand side. So v minus ut equals u plus at minus at. I've subtract, let me change that actually to a different colour. That was meant to be an a. Subtract at from both sides. Take at from both sides. Yeah.
So is AT just one single thing, is it?
T, yeah, good question. Is AT, it's a whole thing, isn't it?
Oh, right. Okay.
It's A multiplied by T, but if I want to get rid of it, I can think of it as one whole term that I'm going to subtract.
Okay, so how do we do that then? Because if AT is like, we normally would have times it, wouldn't we?
Yeah. If I know A and T, if say A was 3 and T was 4, 3 times 4 is 12, I would still subtract 12.
Oh, right.
It doesn't matter what A and T are, I'm subtracting a whole lot. Does that make sense? So I just write that, minus AT, minus AT. That means AT minus AT, 0. I've subtracted it. 12 minus 12 is nothing. So they cancel, and I'm just left with U. So finally we can write V minus AT equals U. And I've rearranged that formula for U, so I put U on the left hand side as the subject. Okay, so what we've been looking at today, we've been looking at engineering notation and standard form for large and small numbers, and we've been looking at using the calculator and just started to look at rearranging formulae. So, back row, what's come out of today? Anything to do with any of those things that's worth writing down here? About those things. Engineering notation, using the calculator, rearranging formulae.
When rearranging formulae, you've got to do the same thing both sides.
Okay. When rearranging, that's a key thing, so thanks for that. Do the same thing to both sides. Middle bench. Anything to take out of today? Yep. Okay. To do with engineering notation that you've taken away from today, or to do with the calculator? Any?
Engineering notation is always in power of multiples of 3.
Right. Okay. Engineering notation, multiples of 3. Of 3. Because it fits with prefixes. Okay, front row. Buy a good calculator. At the back, apparently, £1.95 from Tesco's. They're on special offer.
These?
Yeah.
Nah.
That, £1.95.
£6.
£1.90.